Okay, so solving systems with matrices. So the very first thing that we need to do is make a matrix out of my system. Keep in mind what our end goal is. I need ones down the diagonal. So looking at my first variable, I need the first position in my matrix to be a 1. If I possibly have a front coefficient that's a 1, I can put that equation first and be done with my first step. Okay? So I'm going to go ahead, I'm going to pick this second equation right here to go first. So remember, when we're writing our matrix, it's just the coefficients that go in. So I'm going to write the first equation first. So I'll have 1, -2, -3, 2. And then the other orders don't really matter. So I'm going to put the first equation, so 2, 4, 1, 1. And then the last, 1, 1, -1, -1. And before you get started, be sure and check that all your coefficients are correct. You have negatives in the right spot. If you forget the negative, and the whole problem from here on out is not going to be right. Okay, so again, we need the values along this diagonal to be 1s, right? That's going to be our end goal. Make these 1s, and then we'll use elimination to make everything below it 0s, right? So the first piece is already 1. So now I'm just essentially going to use elimination to make everything below it cancel out, make everything below it 0. So for the second row, I have a 2. So I need a -2 to make it cancel out. So I'm going to multiply that first row by -2 and add that to the second row. Then -2 plus 2 will give me 0. And with the same thought process, essentially, I need the value in the third row to also be 0. And then again, by elimination, it's a +1, so I need a -1 to make it 0. So I'm going to use that first row again. And I'm going to do -1 times row 1 and add that to row 2. Row 3. That's right. Good job. Row 3. All right. So my row 1's not going to change. It needs to have a 1 right here. It already has a 1, so I'm done with row 1 forever. All right. So I have 1, -2, -3, 2. It didn't change. Row 2, I'm taking -2 times row 1 and adding it to row 2. So if you need to come out to the side and write what that is, we can. So if I multiply row 1 by -2, I get -2, +4, +6, -4. And now these are the values I'm going to add to row 2. So -2 plus 2 gives me 0. 4 plus 4 gives me 8. 6 plus 1 gives me 7. And -4 plus 1 gives me -3. Check my arithmetic. And now we'll do the same exact thing. I'm multiplying -1 times row 1 and adding that to row 3. So again, if we need to come out here, write down what those values are. -1 times row 1 is going to give me -1, +2, +3, and -2. Now I'm adding these values to row 3. So -1 plus 1 is 0. 2 plus 1 is 3. 3 plus -1 is 2. And -2 plus -1 is -3. All right, so notice column 1 is in the order I need it in. I have the 1 at top, and everything below it is 0. So I'm going to move on to column 2 now. Now I need this 8 to be a 1. So we may have to deal with fractions with the matrix, but that's okay. So in order to make this 8 a 1, I need to divide it by 8. So I'm going to do 1/8 row 2. So my top row stays the same, 1, -2, -3, 2. My middle row, 0 divided by 8 is 0. 8 divided by 8 is 1. 7 divided by 8 is 7/8. And -3 divided by 8 is -3/8. And again, my bottom row stays the same. So I have 0, 3, 2, -3. And now, so I'm working to get this diagonal to be 1. So I have the first two to be 1s. Now with this 1, I need to use elimination again to make the values below it 0. So the value below it is a 3. By elimination, what do I need to cancel out positive 3? Negative 3. So I'm going to use, I'm in the second column, so I'm using the second row. So I'm going to multiply the second row. I need negative 3, so I'm going to do negative 3 times row 2 and add that to row 3. Okay. So again, top row is not going to change. I have 1, negative 2, negative 3, positive 2. Middle row, I'm done with it, so it's not going to change. I have 0, 1, 7/8, and negative 3 over 8. But I'm going to multiply that middle row by negative 3 and add it to the last row. So I can come out and write what it'll be when I multiply by negative 3. I'll just write it underneath. So negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Negative 3 times 7 over 8. Remember, when we're multiplying fractions, top times top, bottom times bottom. So this gives me negative 21 over 8. And negative 3 times negative 3 over 8 gives me 9 over 8. And now I'm adding these new values to my bottom row. So 0 plus 0 gives me 0. Negative 3 plus 3 gives me 0. Negative 21 over 8 plus 2. Find your common denominator, whatever you need to do. It would be 8, so this is 16 over 8 minus 21, which gives me negative 5 over 8. And same thing, common denominator would be 8, so I have negative 24 over 8 plus 9 over 8, so negative 24 plus 9. Negative 15. Fractions are our friends. All right, so the very last piece, I have zeros on the bottom, which is what I needed, and I want ones all down the diagonal. So this is negative 5 over 8. To make a fraction 1, just multiply by the reciprocal. So I need to multiply this by negative 8 over 5. Right? So I'm going to do negative 8 over 5 times row 3. Everything else stays the same, so I have 1, negative 2, negative 3, 2, 0, 1, 7 over 8, negative 3 over 8, and 0 times negative 8 over 5 is 0. 0 times negative 8 over 5 is 0. Negative 5 over 8 times negative 8 over 5 is 1. And negative 15 over 8 times negative 8 over 5, my 8's cancel out. A negative times a negative is a positive, and 15 over 5 is just 3. Alright, so now that I have ones all down my diagonal and zeros on the bottom, I can go ahead and pull out the equations and see what I have. Remember the first column, these are my x's, these are my y's, these are my z's, and these are what they're equal to. So starting with the bottom equation, I have no x's, no y's, but it tells me that z is equal to 3. Now using that, going back, the second equation tells me that y plus 7 over 8z equals negative 3 over 8. And I know we don't generally like dealing with fractions, so you can get rid of it if you want to. The common denominator here is 8, so I can multiply through by 8 and get rid of it. That would give me 8y plus 7z equals negative 3. And we know that z is 3, so if I plug in 3, I get 8y plus 7 times 3 is 21 equals negative 3. Subtract 21 from both sides, and I get 8y equals negative 24. Divide by 8, and I get y is equal to negative 3. And now, using the very top equation, the top equation, let me scoot up, tells me that x minus 2y minus 3z is equal to 2. Well, we found that z is 3 and y is negative 3, so I'll plug those in. So I have x minus 2 times negative 3 minus 3 times 3 equals 2. So I have x plus 6 minus 9 equals 2. So x minus 3 equals 2. So x is equal to 5. So again, we end up with 5, negative 3, and 3.